Now let's talk about turbulence and turbulent noise. In the module library, you'll find them on the Filters tab. Right down the bottom, I've got turbulence and turbulent noise here. So I'm going to drag turbulent noise first into the network and plug it into the main composite. And skipping back to the camera view, we don't see anything here because this is a mathematically generated effect and it'll only be visible once you render the frame. So I will render this frame, and still we don't see anything. It's just a flat field of grey, and that's because we don't have any values in the layer properties. We haven't entered anything. So the first thing we want to enter is a frequency value. So I'll just enter a value of 5 here, and right away we've got this field of black and white with the transitions between. This noise pattern, as we can see, has a frequency of 5, both X and Y, but we can separate those values. If I have just an X value of 5 and no value in Y, we can see we have a vertical ray effect because across the X-axis, which is from left to right, we have a frequency of 5, but on the Y-axis we have no frequency. If I swap that around, we have the frequency only happening on the Y-axis, which is from top to bottom. So I'll change that to 5 and 5. We're going to skip the offset section here. This is the panning values of the effect, but we'll see that in action in another scene in an example. So let's skip for now to the evolution. The evolution value is the noise, the changing of the noise. So with a value of 0, we don't have any changes happening. In order to see the change happening over time, we need to animate this value. So the first thing I want to do here is apply a function curve. And on frame 1, I'll add a keyframe and give it a value of 0. And skip ahead to frame 60 and add another keyframe, but give the second keyframe a value of, say, 5. So that over time we see the value, the evolution of the noise goes from 0 to 5. And if I step through the frames, we can see now that the noise is changing. It's evolving. Over 60 frames, it's evolving from 0 to 5. So by this, you can see that we can change the speed of the evolution, the speed of the noise effect. So instead of a value of 5 on frame 60, if I put this up to a value of, say, 30 on frame 60, our evolution is much quicker, and we can step through the frames now and see crazy stuff going on. It's like time lapse. So I'll put that back to a value of 5, so I've got something a bit more gentle. The complexity section is going to be easier to understand when we look at different types of noise. So the default noise type and fractal types are Perlin and fractional Brownian. You can see those at the top of the layer properties. So let's just go through these lists. They're only short lists, but the combination of these will give you unique effects. So let's start with the noise type and we'll go through them one by one. So after Perlin, we've got a simplex pattern, a sinusoidal pattern, I think that's how you pronounce it, a subscaling, rocky, and small bumps. And you see that each of these has a different, a unique look. And next is the fractal type. We're on fractional Brownian, but we'll start at the top of the list with turbulent twist. You can see this is a very, very graphically interesting effect. So turbulent twist, we've seen fractional Brownian. The next one down is threshold. The next one is invert threshold. That's the opposite of that. And terrain is the last one in the list. So experiment with the combinations of these to get different noise effects. And then you can play with the frequency values as well to give it a more broad or more intricate transition. So next up, we'll look at the combinations of these in different situations. So the first example that I'd like to show you is an animated light beams effect. Traditionally, this would be quite difficult to do or time-consuming and tedious just because of the really gradual and smooth movement of light beams. But let me show you the scene first. I've got a fish swimming through the scene and some bubbles rising. The fish has a bit of a directional blur to give him the hint of a shadow, and he's got a little highlight on top, but otherwise the background is just a simple blue to blue gradient. So this is the animated scene. If I press play here, You can see it's quite atmospheric already, but I'd like to add some light beams, animated light beams coming from the waves above. So let's have a look at how to do that with Turbulence. So I'm going to switch over to the network view, and I've got the turbulence turned off, all the turbulence effects. You can see here we've got the fish and the bubbles and his directional blur and his highlight are there. And I've also got a background, I've called it sky, but I've got just that base color, that blue gradient that you saw. So I'll switch back here. The reason I've got these turned off is because I'm going to turn them on one by one to show you how the turbulence works and then how we treat the effect to give it the final look. So I'll switch back to camera. I'm going to turn on the turbulent noise first, and you can see here that it's straight down beams of noise, and I've done that by, as you saw in the previous section, separating the frequency with and I've only got a value in the X. So I've got a value of 4 and a 0 value in the Y field. So that gives us vertical straight beams. The next thing I've done is I wanted to put a variable opacity on this. So the beams start strong at the top and they fade off as they get lower. So I've used a cutter which looks like this. It's transparent at the top and white at the bottom, and I'm using this as a cutter, and that will gradually cut off the beams. So when we look at them all together, we get this effect. Let me turn that off there. So this is the white beams going through the blue gradient, and they're fading off gradually because of the cutter that I've got. Now the next thing I wanted to do is to add a bit of blue. These white beams don't look very good coming through a blue ocean. So I added a hue saturation module, and we'll look at that a bit later. But I added that with a colorize effect on it so that we're coloring the beams with blue. And once I turn that on, we're starting to see something that belongs, light beams that belong in under the water. So the next thing to do is to squash the beams at the top slightly so that it looks like they look a bit more directional, because currently straight down is a little bit boring. So I used a quad map for that, and I used the quad map on the turbulent noise. And if you remember, the quad map allows you to distort by dragging handles around. So if I drag this, you can see how that works. So I'll turn off the quad map. And we're pretty much done, but one last thing, is I would like the beams to, they're sharp at the top, but I would like them to get more blurry as they go down. So I've added a variable blur using the cutter that I used. I'm using the same artwork for that on the variable blur. So I'll turn that on, and now we have the beams are going from slightly blurry to more blurry as they get lower. Now there's one final step that we haven't taken care of yet, and if I play this preview here, you'll see what it is. The light beams don't animate at all, so that's because we haven't set any values for the evolution. So I'm going to close that, and I'll create a function curve in the evolution section, and on frame 1 I'll set the value, leave the value at 0. And on frame 60, the last frame of the scene, I'll set another keyframe, and I'll put in a value of, say, 3. And hopefully that'll give us a nice, graceful looking effect. So that's rendered now. Let's have a look. Ah, much better. What a lovely, lovely scene. Now this effect is one of the ones I'm most excited about, because underwater caustic effects, caustic refraction, is next to impossible to do in 2D animation, and I've been trying to do this kind of thing for many years. So that's why I was so excited about the addition of Turbulence in this version of Harmony. So let me step through the frames here so you can see what this is. I've got the noise type set to small bumps and the fractal type set to terrain. And this gives us kind of like wobbly lines. And this will give us an opportunity, this particular type of noise will give us an opportunity to look at the complexity, which I skipped over in the previous section. So as you can see, this is as I step through the frames, you can see the lines are moving. There's a few too many straight lines in this particular style for my liking, but they you don't tend to notice them when the thing is moving. But let me just decrease the frequency to 2 and 2 so we can get a closer look at these lines. Now, what I was talking about before with the complexity, and you can't really see it with the other types of turbulent noise, but with this type you can really see the strings and what these values mean. So if I put the complexity on 1, you can see I have one layer of strings. And now if I put the complexity on 2, I have that layer of strings plus a layer underneath of more strings that are a bit more faint. With the faint ones, the reason they're more faint is because I have the gain set to 0.7. If I put the gain on 1, you can see they are the same brightness as the top layer of strings. So I'll put that back on 0.7. Now for the subscaling, this means that they're smaller than the top layer of strings. The bottom layer is smaller. So, and if I put that on, the subscaling on 1, they're the same size. So I'll reduce that back down to 2. In fact, if I reduce it down to 3, you can see it's even smaller. So I was pretty happy with the 2. And so let's start building this scene. Actually, before I do, I might just set the subscaling to 1.4, just so that the bottom layer of strings is only slightly smaller than the top layer. And I've got the evolution working. That goes very slowly. It goes from 0 to 1.6 over 200 frames. So that's a very slow, gradual movement of the noise. And if I step through the frames, you can see how gradual that is. So let's switch across to the network. And I'd like to show you first how you can how to turn a caustic effect into a matte that you can use for things like cutters and variable blurs and refraction. And you can see here that I've got a grayscale module. In your module library, there's your grayscale, just drag it in. And it's important to check the matte output checkbox. And this allows the turbulence to be used as a matte. So you can see here I've got it plugged into a cutter, which is cutting out the seabed color. So I'll activate the seabed color, and if we go back to the camera view, you can see that this is now a matte cutting out the seabed color, which is this. This is just a seabed color, the caustic color, and that's how it looks when it comes together as an effect. So the other thing I've got in here is a peg which tilts the effect over in 3D. So I'll activate that. I'll go back to the camera view first so you can see it. And now I'll activate this peg, and you can see now it's sitting on the floor of the sea, the ocean. And I can step through the frames here and we can see the effect moving. So this is going to look great once it's rendered. The other thing I had to do, I'll just take that off. The other thing I had to do is I had to cut this effect so that it fades off in the distance, because as you can see back on the camera view, it goes all the way to the horizon and it just cuts off. So I've got this cutter that gradually cuts off the effect so it fades into the distance rather than just cuts off too hard. So the next thing is I created a background that goes behind this. If you remember that the black here represents transparency, I turn on the background, which switch briefly across to the network view. The background is plugged in underneath all this, and I activate that. And if we go back to the camera view, you can see how that just really comes together nicely. And finally, just as a final touch, I added a shadow of a shark going across that is acting as a cutter. I'll go back here. You can see that the shark shadow is animated. It's on its own peg, but it's plugged into a cutter here, which cuts out the whole turbulence effect. So it's effectively blocking out the light as it goes past, which you can see here, which really comes together nicely. And I think combined with some bubbles and some fish and some more overhead light beam reflections, this might start to look like something that you would never expect to have been done in 2D. And here we go, 200 frames of caustic effects, which I think looks incredible. So this is a slightly more simple scene. I'm going to be using turbulence this time instead of turbulent noise. Now the difference between turbulence and turbulent noise is that we can see turbulent noise visually on the screen, but we can't see turbulence visually on the screen. We can only see its effects. So what we're doing here is we're applying turbulence to a background rather than to a grayscale matte. So I'm going to apply the turbulence in this scene to the reflections here. And the reflections, I've put them all in one composite so I can treat them as one. I'll skip across to here. You can see I've got the boat reflections, all the reflections, the background and the boat reflections are together in their own composite. And I've got a little transparency module on there so that they're a little bit faded. But I'm going to drag turbulence this time and plug it in underneath. So turbulence has two ports. The top right port is where I'll plug the artwork. And now I skip across to the camera view and we'll work in the layer properties and watch the effect update as we adjust these properties. The first properties I'm going to play around with are the amount and the frequency of the turbulence. And as I change these values, watch the reflection in the camera view and see how they're affected. So first of all, I'm going to put the frequency on, say, 5 again, and nothing's happened, and that's because the amount is at 0. So I'll put the amount on, I'm going to go crazy and put it on 100. And so on 100 you can see we've got a definite visual effect. So with the frequency at 5, let's try a different value. I'll put the frequency on 50, and now we've got something that's really gritty and kind of granular. And I think that's a bit too gritty and granular. So I'll go back to about 20 maybe. That's starting to look a bit better, but it's still not very cartoony. It looks very composite-y. So I'll try a 10, and that's looking a bit better, but it's not quite as crunchy as I'd like. So I'll put it on 15. There we go. So 15 is about it looks like it's got the amount of wobble that I want, but it's a bit too intense. So that goes back to the amount field. So I'm just going to put the amount back to, let's try 50. Okay, and it's looking a bit more subtle, but it's still quite high. I'll go back to about 20. Let's try that. Okay, that looks a lot better. So now I'm going to adjust the evolution so that we actually get some motion in this water surface. So I'll create a function curve once again and add a keyframe with a value of 0, and then at frame 60 I'll add a keyframe and I'll make this value, let's try say 12, see what happens. Okay, now if I go back to frame 1 and step through the frames, I can see a very subtle motion going on, especially on you can see it moving on the fishing rod because it's very thin. It's easy to see the effect. So I think that is actually quite good, and I might render this scene as is and see if I've hit the jackpot first time. So here we go. I'll press play. Okay, so this is moving. It's moving well and it looks good, but I think it's a little bit too fast. So a value of 12 on the evolution was a bit too high. So I'll close that, go back to the evolution and put it down to, let's try 6. No, let's try 7, slightly more than half. Close that and re-render. And let's watch this again. That's looking much more natural, which I'm very happy with. So this is updating the turbulence by watching its effects in the scene, rather than looking at a grayscale matte and then applying that. So as a final example of turbulence, I'd like to show you this one. I step through the frames and you can see it moves upwards very fast. And if I open the layer properties, we've got a purlin type with turbulent twist, and I've got a very vertical effect because I've got the X frequency at 2.5 and I've got the Y frequency at a very low 0.23. And I've got a huge offset, Y offset movement. So it's a panning movement. The Y offset goes from a value of 0 at frame 1 to a value of 60,000 at frame 60, which means it moves 1,000 per frame over 60 frames. And that gives it all this upward motion. So you can probably guess at this point what I might be using this for. So let me just give you a look at the network. This is the turbulence. I've got a grayscale module plugged into it so that I can use it as a matte, and that's so that I can use it with this refract module. But I've got it plugged into what I've called a fire gradient. And if I go back to the camera view, you can see what I'm about to do. So with this gradient, I'm using the turbulence to refract this gradient. And if I turn on the refract module, you can see what it's done. It's refracted this so it looks like fire. And if I step through the frames, you see it's quite fast and flickery. I was working on this for a while trying to come up with something that looked fairly realistic. But in the end, it's no substitute for real fire, but it's pretty convincing, especially if you can get the values looking right. So I'm going to, in the background I've got just a silhouette of a house, so it looks like kind of there's a fire coming towards this house or something scary. So I'm going to render this, and here we go, let's play. So it doesn't look too bad. I mean, it's not very cartoony, it's not very 2D, but it just shows what you can do with some turbulent noise. Once again, this is turbulent noise, this isn't turbulence. So that wraps up this section on turbulence. In the next video, we'll look at some new color adjustment modules, lens flares, and a couple of UI enhancements.